Hello everyone. So this video is going to be about the projectile motion, and in this specific video we will be discussing about what exactly is projectile motion and how can you derive the parameters through which we describe this motion. So suppose we all know that we have taken a ball projected into the air at a velocity v from the horizontal at an angle theta. So how does it go? You all know it looks something like this, correct? It lands finally at here. So what is the equation of this curve? We call this as equation of trajectory. Now what is the horizontal distance it covers across the ground? This is known as range. And during this projectile, what was the maximum height it covered? This is h. So h is nothing but maximum height. And the final parameter is time of flight, which is the time required by the ball to complete its projectile and return to the ground. How much time it took? This is nothing but time of flight. Okay, so whatever approach we are going to discuss for derivations, that same approach will be carry forward to solve any type of projectile problem. So let it be this, very common, and also this projectile on inclined, or anything, whether you include magnetic field, electric field. So the approach remains the same. Okay, so let's dive straight into the derivations and get to know this approach. Okay, so let's proceed. Okay, so equation of trajectory, how do we derive this expression? So let's make the diagram once again very fast. Theta, this theta, and let's consider one point x comma y on this projectile, and let this be origin. So to reach this x comma y point, the projectile has to cover x distance in x direction and y distance in y direction. Okay, this is clear, right? So now our job is to, this is nothing but a 2D motion. Okay, now our job is to divide this whole motion into two parts, x direction and y direction. Okay, so let's list down all the parameters in x. So how can we say it? Ux, which is u cos theta. Okay, taking the components, and this is u sin theta. So ux is u cos theta. Ax, acceleration in x direction, 0, because we are only considering the effect of gravity for this derivation. Sx will be x as discussed. Now coming to y direction, uy will be u sin theta. Okay, initial velocity in y direction. Ay will be minus g and sy will be y. So this is what we have done. We have listed down all the parameters required. Now let's derive further. So what is the equation which contains these three parameters? It's a second equation of motion. Okay, so for x direction, it will look like Sx is equal to uxt plus half axt square. Ux is u cos theta into t plus 0, because ax is 0. That's why, and Sx we can replace it as x. So this become u cos theta into t, our first equation. Okay, now coming to y direction. So we can again write it as sy is equal to uyt plus half ayt square. How will it go? U sin theta into t plus half minus g t square, and here sy will be y. Now pay attention to this. Okay, we rewrite once for clarity purpose. minus half g t square. We have this equation 2. Now see this time term. So to reach x comma y from 0 comma 0, the projectile, whatever time it takes to travel from this point to this point in x direction, will be the same thing required, same time required to travel y distance in y direction, right? So the thing is that this time from equation 1, which is t is equal to x by u cos theta, we can use this same time and substitute it in this equation. What do we get? Let's write it down here. Is it visible? Okay, so let's write it. Y is equal to u sine theta into x by u cos theta minus half g x by u cos theta square. Okay, we bring it inside. Simplifying further, u cancel, x sin theta upon cos theta is tan theta minus half g x square by u square cos square theta. Okay, so rewriting it perfectly, we get y is equal to x tan theta minus half g x square upon u square cos square theta. So this is nothing but our equation of trajectory. Equation of trajectory. It is nothing but in the form of y is equal to fx. This tells us that how does the path will look like? How will this path look like? This equation right here is nothing but the equation of this path. Okay. Is it something similar to mathematics, students? Yeah, it looks something like y is equal to ax square plus bx plus c, isn't it? And what is this equation of? It's the equation of parabola. Correct? Okay. So this is how we have derived the equation of trajectory. So now let's discuss about time of flight. So what was the definition that we discussed? It is the time required for the ball to start from the point of projection to where it hits the ground. It basically tells you the time for which the projectile was airbound. Okay, so how do we derive it? I want one hint from you guys. What is that one hint you can find between the origin and P? So think, pause. I will tell the answer that it is both origin and P are on horizontal. What does this mean? What does this mean? That the displacement throughout this motion in the y direction is 0. So Sy is nothing but 0 because it goes up and again comes down to the same horizontal level where it started. This makes Sy to be 0. So now we can substitute this half ay t square, Sy is 0, uy is u sine theta into t plus half minus g t square. How do we simplify it further? Half gt square is equal to u sine theta into t, t cancel, and you get t as 2u sine theta by g. This is nothing but the time of flight. Okay, this is what you call it as time of flight. So the main thing to notice is, from where did we get these values? Yeah, it was from this table which we have already made. So this making this table is important. Knowing that we have to divide this motion into two equal parts or two parts, x direction and y direction, is important. Okay, so this is the expression which we get, and basically this is the time for which the ball is airbound. Now coming to the derivation of the range. Again, how did we define range? It is the horizontal distance covered by the ball during its projectile. It is the horizontal distance covered by the ball during its projectile. So again, this is u cos theta, u sin theta. We are dealing with x direction here, so x direction equations plus half ax t square. Ax is 0 because again we are considering only gravity. Sx is r. This is the distance we are taking into account while solving this problem. Ux is u cos theta. And what is the time? What is the time now? Yeah, correct. It will be this time itself, because this is the time for which the ball goes from here to here, and in the same time, basically it means that it traveled this distance along x. Okay, so substituting the time of flight expression, we get 2u sin theta by g. Further, this is u square 2 sin theta cos theta upon g. We know that from trigonometry, 2 sin theta cos theta is nothing but sin 2 theta upon g. This is the expression for range. This is the expression for range. Okay, I hope it's clear now. So now let's derive the expression for maximum height h. This thing. Okay. So how can we derive it? What is the hint we need here, as in case of the range that we discussed already? What is the hint that we can take? Notice that there is no acceleration in x. The only acceleration which exists is g, which is in y direction minus g. Ax is 0. So what can you comment about this velocity? Yeah, it will be constant throughout. U cos theta, u cos theta, u cos theta, u cos theta, u cos theta. Correct. And now what can you comment about the y direction velocity? This u sin theta, will it be constant? No. Why? Because this minus g component, the velocity is in upward direction but acceleration is in downward direction. This will decrease its component till this point. Okay, after which, since it is 0 here, the y component velocity, after this direction, after this, for this portion, it will start again increasing this y direction velocity. Okay, so this is how the projectile works. What can I comment about this point M? So at point M, Vy will be 0. And what can I comment about Vx? It will be u cos theta. Okay, and this is the point where I need to focus, at point M, because this point is what will give me the maximum height. So I have the final velocity, I have the initial velocity in y direction. What is the equation? And I need distance. What is the equation among the 3 kinematical equations which can help me to get to this? I guess it is v square is equal to u square plus 2as in y direction. So y, vy is 0, uy is u sin theta square minus or plus minus g into h. Correct? So this will be u square sine square theta minus 2gh. I will take it to this side. It will be h is equal to u square sine square theta. It will be h is equal to u square sine square theta upon 2g. So this is the expression for maximum height. Okay, so what is the core? What can be the core of this concept? Derivations is okay, but I will say that this, making this table, dividing the whole motion into two parts, x direction and y direction, is important because this enables us to get a clear picture of each dimension. Okay, so this is how we will be solving uh, the complicated problems further in next videos, upcoming videos. But the main thing to consider is this. So keep this in mind, and then derivations are very easy.
Okay, so you can also go through our article on www.physicsandelectronics.com, where you will get this article which completely summarizes this video in text form. It is in the article form, which you can also use it for your future reference while revising your whole syllabus.